Good morning students. In this class I will be doing class 10 CBSE syllabus 10th chapter circles. This is a new chapter. In my previous class I had completed triangles chapter. From this class I will be doing circles. This is the 10th chapter. Only one exercise we have with only 16 sums. First exercise is very simple. Only fill in the blanks and true or false, only like that we have. Second exercise, but all the sums are very important. Okay, so now we'll go to the introduction part of the circles. So you know about circles. Radius, diameter, secant, radius, diameter, segment, sector, all these things you have learned in your lower classes. These are the parts of the circle. One important thing other than those things are tangent and secant. So when you take secant, the meaning for the secant is a circle is there when a line segment touches the circle at 2 points, that is called the secant. When a line segment touches the circle at any 2 points, that they are called the secant. And then tangent is the special name given to the secant, that is when this line is moving towards like this, it will meet at only 1 point. So a line that meets the circle at only 1 point, that is called the tangent. So this is the special name given for a type of secant. Okay, so these things are very important. How we are going to deal with this tangent and secant only we are going to do in this chapter. Now theorem 10.1. So two theorems are there. Both the theorems are very important. So the tangent at any point of a circle. So if a circle is there and a tangent is there. Tangent means if a line touches the circle at 1 point, that is called the tangent. So your tangent at any point of a circle, is perpendicular to the radius. So if we draw a radius, that will be perpendicular to the tangent through the point of contact. So point of contact means the point where the circle and the tangent meets. That is called the point of, at 1 point only it will meet. Since it is a tangent, at 1 point only it will meet. That point is called the point of contact. So that will be the shortest distance. So that perpendicular distance will be the shortest distance. So there is a proof given for that shortest distance. When we take OA, okay, OA is the radius of the circle and this XY is the line. Okay, so when this OA is the perpendicular, then if we draw any other line other than that, if we make it as OM, since this OA is the radius. Okay, so with the help of this radius only a circle will be drawn. If we take some other point other than this, that is outside the circle, that will be, if it is outside the circle only, it will touch that tangent point, the tangent line. So that OM will be bigger than this OA. Why? Because this OA is the radius. With the help of that radius only, we are drawing a circle. If the point is more than that, definitely that radius will be the shortest one. Okay, so the OM will be greater than this OA. This OM, the point, if we take some other point on the tangent line and if we join that length will be, that is the length of OM will be greater than this OA. Why? Because OA is the radius and M is a point on the tangent. When we join that tangent, that will be outside the circle. That M point will be outside the circle. If it is outside the circle, it will be greater than the radius. So this OA is perpendicular and that will be the shortest distance from the center to the point of contact. So this proof is important proof. Then theorem 10.2. The length of the tangents drawn from an external point to a circle are equal. So a circle is there, a point is there, external point is there. The length of the tangents drawn from an external point. So we may get many tangents. So from this point, if we are drawing a tangent, the length of the tangents will be equal. The length of the tangents drawn from an external point to a circle will be equal. For this also a proof is given. So if we join this is the external point and this is the tangent. So we'll make this as OABC. So we need to prove AB is equal to BC. That is the length of the tangents are equal we need to prove. So for that this O is the center point of the circle. When we join this, just now we have proved that the point of contact, that is the tangent and the radius will be perpendicular to each other. So we'll get a right angle triangle here. So OB square. So we can prove the congruency of both these triangles. That is OAB and OCB. We can say the congruency. So what are all the congruency parts we will get? OA and OC are the radius. That will be equal. OA is equal to OC. That length will be equal. OB is equal to OB. That is common. And both these are perpendicular. That is right angle. That is angle A is equal to angle C. Both these are 90 degrees. So by RHS congruency we can say that both the triangles are congruent to each other. Since the triangles are congruent, the sides are equal. That is AB is equal to, by CPCT we can say that AB is equal to BC. So this is by CPCT. So this is the proof we have to give for the theorem. So this theorem is also very, very important theorem. So based on these theorems and secant and tangent properties, we are going to do exercise sums. First exercise is simple. Second exercise we will do. Okay.